Okay. Hi, everybody. Good to see such a big crowd here. But it always amazes me at the magnetism of ham radio that brings all these guys out. Because I know each one of you has a lot of your own individual interests. Sometimes individual magnetism gets kind of oriented the wrong way and it fucks. But the ham radio bunch, generally the magnetism is all really good and we're all together. I tried to figure out what to talk about today, and I thought, well, I'm going to tell you about how I got steamed up with ham radio. It might be of interest, and it might not. It might tickle some of you, and maybe it won't. But I got started out in ham radio back when I was about 14 years old. I started playing with my neighbor that had an electric train. And his electric train had a transformer to run the tracks. And we used to experiment around winding wires on nails and looking at the magnetism that made up. We also, the train tracks with nails across them made pretty good sparks. So we learned about the spark fields and so forth. Then later on I ran into another friend of mine that had a 1-tube regenerative radio where I learned to listen to CW and got interested in wireless. That's how I kind of got started out with ham radio.
When was that?
Wireless.
When was that? What year?
And this was back about 1939 when I was 14 years old, about 1939. And so in that ham radio has got to do with wireless. That wireless actually started out with spark. Somebody back around in the 1900s, they got to playing around with wireless and found out that if they made a spark, they could pick it up somewhere else. At first it was very close proximity, and then later on they learned how to tune it up so that they could hook it on the wires and make it transmit a lot further. And so to make sparks, they had to figure out some circuits to do it. Well, one of the ways to do it was to have a transformer where you had a key that excited the primary to a normally closed contact on what was like a relay. So as soon as you energized the circuit, as soon as the magnetism got built up enough, it opened up the circuit. The collapsing magnetic field induced enough voltage in the secondary to produce a spark across the spark gap. The spark gap was then coupled to some other circuits and eventually to the antenna. I won't get into all the details of the tuning, but this was things that the different experimenters were doing at that time. And I was surprised that when I look back at some of that, how many different people were working on wireless. Not only Mark County, but Besden and a few other people that I can't even remember. And later on, they could generate the spark okay, but to figure out how to detect it got to be a little complicated. And they first had some magnetic detectors, and then a thing called a coherer that could detect the incoming spark as well. But the best thing they came up with turned out to be a crystal. So originally it was kind of a catalyst or thing on some kind of a crystal. Later on it developed into maybe iron oxides on a razor blade. Eventually it got developed into the kind of crystals we see nowadays. And this thing has been going on for years. We've got some really good crystals nowadays and with different characteristics and so forth. But this kind of a generator meant that it could generate a series of sparks, because this was kind of an oscillator in that it pulled in the magnetic field and broke it. But once it broke it, it then restarted it again, and it kept sitting there. It was a doorbell. It buzzed. And the buzz rate was what the receivers could hear. If it didn't buzz, when you turned on a continuous wave, it would just go click on and click off again, which didn't mean too much. In fact, the original signal across the ocean was the letter S, because it was just clicks. So then in order to get the rate at which this thing pulls, depending upon the mechanics and the magnetic buildup, how long it took the magnetic field to build up in a coil and operate the mechanism and break. So the rip rate was not really easily determined. But they wanted it to have a rip rate that produced clicks that was a tone. So they went to a spinning wheel that would make and break the spark at a rate that could be governed by the DC motor that ran the field. So now the individual sparks would look like this if you had a time base that was fast enough to catch it. On a slower time base, you'd see a whole string of sparks like this, and you could detect it with a crystal detector by simply picking up the peaks, charging it up, charging the capacitor to the peaks, and it was able to follow the peaks. So actually we had a amplitude modulation going on. So what we were really getting with the early spark transmitters that were operated off the spinning wheel like this was an AM modulated signal. Here's a continuous wave signal where there's no amplitude change. It's just a continuous amplitude, and you can turn it on and turn it off. Now, if you're listening to it with a simple, if you're listening to just the turn on and turn off clicks, you just hear a click on and a click off. But with the detector, it could follow the modulation and come up with a tone. So, and I remember reading stories about the spark transmitters on ships, and how the shore operators could tell the different ships apart sometimes because they had different tones. And they had different transmitter makes that ran different speeds on their wheel, so it made different tones. So anyway, it was interesting to note that maybe the first thing we had was an AM modulated signal to be heard. And also later on when I was in the Navy, I noticed that this was back in 1945 about, when I was in the Navy transmitters all had modulated CW as a choice of transmission. And the reason, I didn't tumble at the time, but I think the reason I had modulated CW was so it could be heard with a simple crystal detector. So that otherwise you just hear the click on and the click off. I remember also trying to hear the ham bands with the broadcast with a shortwave receiver that did not have any big frequency oscillator in it, and all you hear is the clicks. So when you had CW that was broken with a continuous wave that was broken up with Morse code, you had to have some way to get the audio out of it. The crystal detector was the way that was done, and it's been done that way for a long time. Okay, then, so back to my ham radio. I started figuring out to get a to get a ham radio license. I had to learn Morse code in those days. I had to learn 13 words a minute, be able to send it and receive it in order to get a code. So I started listening to my little regenerative receiver. Then I built a little better receiver, and eventually I bought a Sky Buddy receiver, which was the bottom of the line of the Hallicrafters, which was a receiver that had 4 bands on it. There's a big dial here that presented the 4 bands, and it had another dial from 0 to 100 that was the band spread of any part of those bands. So you could set the main dial up at the bottom end, say, of a 40-meter band, and then the band spread would spread it out over the 0 to 100. It covered just about the whole 40-meter band, the whole 300 kilohertz. At that time, the whole 300 was CW only. And I thought, this is great. I'll get on that band so that I won't be tempted to listen to the phone guys. I'll learn how to copy Morse because I gotta have it to get the license. And that's why a lot of the old guys, all these old guys still using CW, but we had to learn it, and we learned it good enough so it sticks with you. So, why not? So like I was just mentioning B-band to you, I haven't been doing good on HF because there's too much noise in my apartment. But the B-band is no QRM, no QRN, a nice clear CW. You can get on there and practice and talk to guys if you want to. Anyway, I got W9 UFO back in 1941. This was the 9th call area then. They hadn't made the 0 district yet. So my first call was a W9. Later on, I got the 0. Anyway, I started out, and I was up in Nashwauk, Minnesota, which is on the Iron Range. I got the iron ore dumps close by, and a bunch of company houses here. I lived in one of the company houses. I strung a long wire up to the top of the ore dump. Train tracks were close by. You had to have the wire high enough so that the train didn't hit it when it went by. And the vacuum tubes were the thing then. That's how we got good CW, actually, was eventually we went from the spark, we went to vacuum tubes. Vacuum tubes could generate a nice continuous wave. And we could turn that continuous wave on and off with Morse code. So, I this was before I actually got my license. I built a rig that had a 809 in the final and a 6F6 crystal oscillator driving it. And we had to be crystal controlled in those days, so it was a crystal. I had a 7138 crystal. And I didn't know much about wireless in those days. I didn't know much about how do I couple to an antenna. So I just put a couple of loops of wire and stuck it into the tank coil and put a capacitor in series with it. And as I carried it around, I could put a neon light up there and find out, hey, somewhere along the line it tuned up. The other thing you had to have, I didn't show it here, but I did have a milliammeter in series with the B plus to the final so I could read plate current. And the plate current would vary as you tuned the capacitor through. You could find some place where the plate current dipped onto a very low value. This was the resonant point, and that's what you had to hit. If you could tune it to the minimum and tune this till you got a nice glow on your neon bulb, you might be getting something into the antenna. Might. That's about all I knew, but I was able to make some contacts. And I worked quite a few contacts with that. That wire was about 300 feet long, so it was a pretty good off the ends of it. To run the transmitter, I also built a power supply which had a transformer in it, so I had to learn about transformers. It had a rectifier tube in it, an 80. Rectifier tubes usually had two plates, two diodes, so that you could connect it with a transformer with a center tap connection to get direct current. You also usually needed an inductor, a choke, to kind of limit the current that was going to inrush to the capacitors, because the tubes in the circuits were kind of sensitive to inrush. And I chose to use a rectifier that was not a vacuum tube, but it was a mercury vapor tube in there. So when the plate current flowed, it flowed nice and blue. But that blue glow also caused noise in the receiver. So some guys on their high power rigs had a foot switch so that they could run the high voltage only during transmit, so they weren't making all that noise on receive. Anyway, my receiver was a Sky Buddy. There was always a problem of transferring from transmit to receive. I didn't have any good TR circuits. All I did was transmit, switch the antenna to the transmitter, and hope I didn't blow the front end of the receiver out. I did put a neon bulb across the input of the receiver so that would kind of limit the RF into the receiver, but the whole receiver would kind of vibrate when I was transmitting.
So
I didn't have a side tone, but I could hear the I could hear the receiver kind of vibrate.
So did you blow off a receiver to get that experience and know that you wanted to avoid it?
What was that?
Well, you said you were worried about blowing the receiver when you put the transmitter power into it. Did that ever actually happen to you?
No, it never happened.
So you've always been
never
cautious.
happened, but it was kind of lucky, I think. So anyway, I operated quite a bit. I got my license in June, so I operated most of the summer, and I progressed from a straight G to a bug.
June of
And-
what year? June of what year did you get your license?
41.
Okay.
41, June of 41. So you know what happened in December of
Yeah.
Pearl Harbor hit,
Yeah.
and we had to get off the air. So I operated all summer, and I worked the sweepstakes in November. I worked the sweepstakes using my bug in September or October maybe, anyway, whatever the sweepstakes was. And then I had to get off when December 7th came. And during the war,
Well, how did you find out about Pearl Harbor? How did you find out about Pearl Harbor? And you had to-
well, I'd been out in the woods skiing, it was a Sunday. And I was out in the woods skiing with my girlfriend. When I came home that evening about 5 o'clock, my dad told me that, hey, the radio had announced. So I turned on my radio and started listening around. I found out that, hey, I shouldn't be transmitting. We couldn't transmit anymore. So then, during the war, the ARRL kind of promoted using what they called low power, kind of a field strength thing, where you didn't have an antenna, but you emitted enough so that you could communicate very short distances without radiating a lot. And some people kind of did that. And I got one of my buddies, another one of my buddies was interested in MnARTS. So I built a couple of oscillators that were in the broadcast band. And we used broadcast receivers, and we transmitted in the broadcast band back and forth to practice code. I was in a small town up in the woods, and there was only one big broadcast station nearby anyway, so nobody ever heard us. So we were practicing code in the middle of the broadcast band. And I thought, I gotta learn the code, because if I go into the military, I probably want to be an operator. And it turned out I got into the military, but I never was an operator. I signed up for a Navy program and got into it, got training to go into officer training, went to an engineering school and learned about electronics, but I never used the code. In fact, I was still in training when the war finally ended, and we got to go back on 10 meters first. So I took that transmitter I had, I tuned the crystal oscillator, which was on 7 megahertz, I tuned it to the fourth harmonic to get it on 10 meters, and drove the final and worked 10 meters that way. And I worked Tinian Island from, I was down in Iowa at the time training. I worked Tinian Island on CW with that. This was right after the war ended. In fact, I got a big ticket from the FCC because I inadvertently tuned the thing to the third harmonic, which was 21 megahertz, which was not yet a ham band. So they picked me up on 21 megahertz and sent me a big ticket. Anyway, after the war ended, we find, after 10 meters, we opened up 75 meters, and that was terrific. The night before they allowed you to come on, everybody was tuning up their transmitters. So they were getting on and saying, hey, this is Hot Dog, how do you read me? And this is Screwball, what do you know? And it was bedlam the night before, everybody was tuning up. So they finally got 75 meters opened up again, and all the phone guys are blasting away. anyway, I got out of the Navy, and the first job out of the Navy, I went to Michigan State as an instructor in electrical engineering, and also became the trustee for the station W8SH. W8SH was the college station. And we had a nice, initially we had a little war surplus receiver, and there was a lot of war surplus transmitters around. In fact, I picked up a couple of them and learned how to, you had to do a little modification to get them to be how you wanted them. For one thing, most of them operated on 20, the filaments were connected to operate on, the vacuum tubes was 12 volts, and they were connected in, a couple of them were connected in series for 24 volts, so they could operate off a 24-volt aircraft supply. So one of the things we did, we rewired them for 12 because most of our good filament transformers were 12 volts. And so I had to make some power supplies to run them, but we did run a lot of the old military transmitters. They were small aircraft transmitters. They put out maybe 10, 20 watts or maybe 30, 40 watts input. In those days, we didn't have any good output measuring devices that I knew of. Everybody went by input. What was the plate current and the plate voltage? The product of the plate current and plate voltage was the input power. That's what we went by. So we operated there for a while. So while I was there, with the more surplus stuff around, I built a new transmitter, a 1625 vacuum that was very popular in those aircraft transmitters. So I had available 1625, so I put 2 of them in push-pull, drove them with a 6AG5 driver, and made a VFO with a triode 65 and used that as a transmitter. I think the input was maybe only 100 watts. I can't even remember. But again, the output power was indicated with a loop of wire and a Christmas tree bulb connected to it. So you could tune through and get your dip and get the bulb to light up to indicate that the final was in resonance. And again, you coupled in the antenna and worked with that. So I was there at W8 and I was in there at, and my call was W8CNC at that time. And I was there about 3-4 years. And I got a little better in receiver too. I went up to a national NC57, I think. And I finally ran across a receiver that had an S meter in it. And always people were telling you, hey, you're 20 dB over S9. So what's dB? I don't know dB. So I had to learn about.
So what kind of work were
I
you
had to
doing?
learn about what that dB was.
What kind of work were you doing?
Oh, I was instructing electrical engineering at Michigan State, and that was a grand, glorious ham radio thing. I used everything that my whole ham radio background, building stuff, circuits, vacuum tubes, whatever was what I was passing on. So I was learning as I went, but I was young enough to think I would knew something. So and a lot of the guys were, in my class were ex-GIs. They were military guys that had been through some electronics already. And so it was kind of a tough route because those guys were on my butt a lot for things. One of the main things was I grew up with electricity. Electricity was, we took a battery and we thought, hey, something came out of the positive terminal of the battery, and that something went through the wires, through the resistors, through the back to the ground end and back to the negative side of the battery. Somebody back then decided that was electrical current. The GIs came back and, hey, we studied electronics. The electrons are going the other way. The electrons are coming negative. They're coming from a hot cathode and going to a plate and going back into the battery at the positive end. So we had two opposing theories there. So I had to tell, hey, I don't care which way you think of it, but you use one way and stick to it. You can't mix them up. If you use conventional current, stick to it. If you use electronic flow, stick to it. But most of the textbooks at that time were the old. They were the old conventional current. Consequently, when I think when solid state got dreamed up, the first diodes had arrow points in the direction opposite of the electrons. The arrow points like conventional current. So I found that, to me, real handy, because that's what I still use. I see a transistor and I think the current's going in the base and out a junction transistor anyway, going in the base and out the emitter. So anyway, that was one of the things that was kind of different. But anyway, I ran into this dB thing and I thought, what the hell is dB? And I found out, hey, that's sound power, and it really got started with Graham Bell when he was working with the telephone. And it got named after Bell. So I thought, well, hell, Bell must mean that a decibel must be 10 bells. I mean, 10 decibels must be 1 bell. Well, nobody ever uses bells. I've never ever seen that stated. But what you do see is that a dB is equal to 10 times the logarithm of a power ratio. So I had to get that through my head that, okay, here we got, and I also ran into the fact that sometimes people told you that a washing machine put out 10 dB of noise, or a jackhammer put out 100 dB noise level. And I'm thinking, well, this dB is about sound power. It's about what you're hearing. So studying it a little more, I found out it's got to do with how many watts energy of a sound wave is going through a square meter of air. And they tell me that, well, maybe a symphony orchestra on a loud boom put out 120 dB, or maybe a lightning burst with 120 dB. So I got to thinking back, well, if dB has to do with power ratios, and the thunder is 120 dB, we're measuring two ratios. So usually the comparison level has to be something. And if a thunder was 120 dB, that means they were comparing it to something that was 120 dB below that. So it meant that it had to be something like had to be something like this. If you put minus 12 into the bottom over here, 120 dB would equal to 1 watt compared to 10 to the minus 12, or 10 to the minus 12 is pico. So you must be comparing it to 1 picowatt. So when you're talking about noise level of a washing machine or a thunderclap, the base must be around 1 picowatt, because the watts are the watts through the surface of what we're talking about for sound level. Okay, so we're talking about watts and we're talking about comparison. So when we start getting it in terms of our electrical stuff, we've got the 10B, got the formula again. dB is 10 times the logarithm. So what the hell is a logarithm? So a logarithm is how many times do you raise 10? Whoops. How many times do you raise 10 to get to a number? So I'm thinking, okay, here's a little bunch of facts. 10 is equal to 10 times the first, 100 is equal to 10 times the second, 1,000, 10 times the third. So that if the logarithm is how many times you raise it, this exponent here then is the logarithm of the number.
And why is that?
Well, anyway, now the other fact you run into is electrically wise, power is equal to the voltage squared over our resistance. So if we're measuring power in electrical terms, we find a resistor that's putting out heat, we measure the voltage across it, you square it and divide it by the number of this value of resistance, you get the power. Well, if you put that, if you put the C squared over R up here for power, you get this. So if it's the same resistor you're measuring power across, the resistors cancel out, and you know that logarithm-wise, 2 times, if 2 times that, so you end up with 20 times the log of that actual voltage ratio. So you end up with another formula that says if you're measuring power across the same resistance, you can take the voltage ratios. But now you have to multiply it times 20 instead of times 10. So you've got 2 formulas now for measuring dB. If you're using power ratios, you multiply it by 10. If you're using voltage ratios across the same resistor, you can use 20. So anyway, I had to learn that and do all that. While I was at Michigan State, I was still also in the Naval Reserve. I stayed in the Navy. I thought I'd been in for 4 years. I thought I might as well stay in the reserve. So I stayed in the reserve at Michigan State. We had a whole group of guys that formed a Navy Reserve unit there. In the summertime, we could go up on the Great Lakes and get a ship and take a weekend cruise. We called it the Poor Man's Yacht Club. We could put in a 2-week cruise up there if we wanted to. So anyway, I stayed in because of that. I wanted to make a little extra money for one thing, but it was also kind of a sociable thing too, to stay in the Naval Reserve. But Korea came along. I got called back. So I went back in the Navy, and went to the Naval School of Mine Warfare at Yorktown, Virginia, to learn how to run a minesweeper. While I was there at the school, they opened a new thing called the degaussing department, which had to do with teaching about ship magnetism and how to get rid of it and protect ships against their own magnetic field for magnetic mines in mine warfare. So while I was in school there, that opened up and I volunteered to teach there and got the job. So I looked out again, so I didn't have to go to Korea. I stayed there at the school and taught mine warfare. And in those days, whenever you moved, you had to change your call. So I went to W4 SXM then. I went on a W4 call and was there for a couple of years. And there was one other guy on the base that was interested in that radio. So we had kind of a two-man club while I was there. He was a chief petty officer there, and we had a lot of good times together on the base. After I got out, I came back to Roseville and started up doing the things I'm doing today. First of all, I was in a house in Roseville with a wire antenna. Later I moved to Maplewood and then back to New Brighton, where I got a 3-element Yagi in the backyard on a 40-meter tower, 40-foot tower, I mean, maybe 50 foot. I was using, I upgraded it well. The reason I got back in, I did not have radio quite a while. I wasn't doing much. I kept my license. And actually I got interested in flying, and I was doing a lot of flying with aircraft. And it was nice to know Morse code because all the navigational aids in those days had Morse IDs on them, so I could pick that up, those things. And also, back when I was in the Navy, I never was on the radio, but I used light. When I first graduated, I was sent to Guam for a year on a patrol craft. And I wasn't the radio officer there either, although I had full access to the radio room. That's where I noticed about the MCW thing. We had big transmitters, and there were probably 400 or 500 watt CW transmitters. They always had a switch where you could switch to MCW. I never really knew what that was about until I got to thinking about this modulated spark thing. Anyway, I got back to ham radio because I was working at a place where another guy showed up one day and he had a transceiver and he was showing it to me and he said, "It's extra. If you want to take it home and try it." So I took it home and I did have an antenna and I had this transceiver and I hooked it up and tried it. Oh, it was pretty good. I started working guys again. But it didn't have automatic transfer from transmit to receive. You had to switch it. Sometimes when I switched it, I bumped the dial and I'd lose the guy. And I was complaining to my wife about it. And she said, "Why don't you get something good?" And I said, "You know how much something good would cost?" And she said, "Well, I don't care. You're in the basement fooling around with that radio all the time. You might as well have something good." So I got a 10-tech Omni, I think it was an Omni C. Anyway, I went down to the store in Minneapolis and picked up an Omni. And that was really good. And Then another guy gave me a little QRP rig. And I tried that, and oh, that's great. So I started thinking QRP. And I found out that, hey, a lot of guys build their own stuff. I said, hey, that'd be interesting. And then I found about this club and came over and found out, hey, there's a lot of guys that are interested in building. So the technicality of ham radio is started coming back to me. So I thought, hey, this is the steam that I need. This is the science and the technology and the engineering, and the art, the mathematics that I need to keep me interested in ham radio. You know, it isn't all just operating. So the QRP movement to me doesn't mean operating at 5 watts. It means operating with your own stuff, doing experimenting, and having a lot of technical fun with electronics. And then the bonus of it is, if you want to get on the air and talk, you can. And so that's how I progressed with, when I came back to Minnesota, I went back to W0 UFO. I didn't even ask for it. I just put in for a new license from my W4 call, and they sent me back W0 UFO.
Wow.
So I got back my original call. And I went from a 10 tech to a Yazoo rig, and then I started, when I started doing QRP stuff, I learned about Elecraft, and I built a K1 Elecraft rig. That was really good. I still have it. It's a great little rig. And then I built a K2 and then a K3. And so that's how I progressed along with the ham radio stuff. Building stuff, I got into building different kits. Yeah, I built a PSK-30, PSK-31 Warbler, which was a kit put on by a guy named Dave Benson, who is from New York. And he started designing and selling kits. And what gave great attention, I built the kit, and then I worked the actual guy that put the kit on. That was kind of fun. And of course, our friend Craig Johnson, one of our club members, he builds kits, and he always sent me one of his first kits so I could be like a beta tester for him. And that was fun. I did a lot of that. And then sometimes I operated portable with my K1 sitting on the tailgate of my pickup and a wire out to a tree. I found out that an end-fed half-wave antenna was really great for portable. It's not too big. It's easy to put up. You just have to throw the end of it up in a tree. And it tunes real easy just because you can use a nice simple LC tuner to tune it. And it not only tunes on 40 meters, but it'll tune to 20 and 15 and 10 if you want it. It'll tune to any harmonic of the half wave that it was cut for. So that's what I use a lot for portable operation. And but in order to tune it up, you need a directional watt meter. And I found a very simple circuit like this one. And I had just one toroid with 2 windings on it, bifilar winding. Stick the feed wire through the toroid and pick up some voltage and rectify the forward and the reverse. I still don't quite, I can't explain to you exactly how that works yet. I read about it and I got kind of the idea, but I I can't say that I can tell you exactly how that works, but it works good. It's able to distinguish between a forward-going wave and a reverse wave. And that's
How does-
all,
how does it
that's
know
all
the
you need to
difference?
know. You can calibrate it so it will read pretty good watt meter, but all you need to tune an antenna is you want to be able to make sure that you got as much going forward as possible and as little going backwards as possible. So perfectly, you want to all go forward. So the lower the back you can get, the better. So you just run your tuner to get the best you can get. If you can get better than 2-to-1, you're doing pretty good. Because 2-to-1 ratio still is, I forget what the percentage is, but it's not too bad. We're still radiating a lot of stuff. So that's the LC tuner with this watt meter is what I use most of the time for portable work. I was up in Alaska working portable. Here it is with my K1 and my little tuner sitting on a log beside the road. I think I'm plugged into my car battery on that one. See this box sitting here has got a cord on it. It's going to plug into the cigar lighter of the car, I think. So I was using the car battery, although I did have a couple of other batteries with me too. That's how I operate portable sometimes. I took it with me when I went on an elder hostel trip to the Midway Island, which is about 177 west longitude and about 28 degrees north latitude, northwest of the Hawaiian Islands, about 1,300 miles. About 1,300 miles back to Honolulu from up there. Anyway, I was up there for about a week and I was able to operate some. They also had a ham radio station there. So I not only used my own portable stuff, but I used their radio. And I wasn't on there a whole bunch. It wasn't a real, like a contest, but I worked maybe 150 contacts with their station and maybe a couple dozen with my own, and had some fun. Also, I started doing quite a bit of building. This is a voltage monitor thing that we made here one day on a builder bot. I don't know if you guys remember or not, but we made it one time. That's when I got to learning about the use of a microprocessor, because ham radio is really going for the microprocessor. And I really kicking myself for not jumping on computers. At first I kind of thought computers were a fad and I wasn't interested in it. I still pushed the slide rule. And eventually, well, it was my wife actually. My wife was a teacher and she got involved in the Apple II at school. And she brought one home and I got to playing around with it and I, ooh, this is really neat. So then I started figuring out, gee, this programming stuff is fun. And I did a few things. And then I ran across the pickaxe, and this voltage monitor thing was based on a pickaxe. The problem with the microprocessors was there's so many different ones and they were moving so fast that I'd play around with one for a little while and I run into a problem and I put it aside. By the time I decided to pick up with it again, maybe a year went by, everything had changed and I had to do the learning curve all over again. So micros kind of went past me. But anyway, I did a little bit.
Is this the one that you wrote the QST article on?
Excuse me?
Is this that's the one you wrote a QST article on?
I don't know if that was it. I did another one with QS. QSP that was, had a battery monitor.
Okay. Maybe
I
that was
did-
it.
I did one that was a ampere hour meter. I should have done a picture of that. That was what I really liked that one. I used the pickaxe to measure ampere hours put into or taken out of a battery. And there is an article at QST about that,
Okay.
so if you want to look that up. But here's my K, this is my K1 and a battery monitor that's in QST. Also, in being in the QRP thing, I got interested in QRP Amateur Radio Club International, which is a really neat club, I think, to be in because they put out a good magazine, a quarterly, it's quite technical. And I go to the convention, here's the kind of guys you meet at the convention. This is a guy named Reverend Dobbs from United Kingdom, and he's a preacher by profession, but he's also a ham radio operator. And he was a very popular QRP guy. He used to speak just about every year there. So going to those conventions, you got to rub elbows with a lot of interesting people. So I enjoyed that. I also played around some with solar power. This is a solar panel and it has a homemade controller that it's actually like a power supply regulator that I built up to go with the controller. I used to use that for some portable operation too. I used it on field day one year to get some extra points for solar power. And this was, if you want to be real particular, if you couple a dipole, if you want to think you're making the best out of it, you can couple it with a 1-to-1. You can couple it with a 1-to-1 toroid. This is a little bipolar on four-way. And I stuck that toroid into a pipe cap, plastic plumbing pipe cap, and potted it in with a connector and connected it to the dipole. So that's the center of a dipole with the Ballon transformer in it. That works really, it's easy to do and it works good, nice and light, so you can sling it up and use it when you're doing portable. So if I'm not using an end-fed dipole, if I want to take something where I don't need a tuner, this is good. And it'll match directly to a dipole without a tuner. And I also started doing a lot of breadboard stuff. This is one of my, this happens to be a little diode TR switch. In order to the main part of the thing really was you needed to produce a high voltage to back bias the diodes on switching. So most of this circuit here, there's a crystal oscillator with a voltage multiplier string to get up to about 150 volts to back bias the thing. But it's built on one of my favorite methods of building. You were talking about pads on the board. Here's the way I get my pads. I've got a little table saw, miniature, with a saw blade that you can stick through the table just a hair, so you can turn the board on it and nick the board to cut your grooves and make your pads that way. Also sometimes if I'm tinning, if you don't have a solder pot, it's easy to tin solderable wire. That's another thing. The winding toroids get solderable magnet wire. Be sure you got magnet wire that you can heat up with a soldering iron to get rid of the insulation. There is magnet wire that does that. A lot of people do that, but they don't talk about it a lot. But I was in the transformer business for about 15 years, and I used a lot of solderable magnet wire. So get solderable magnet wire, and you can tin it by just taking a corner of a PC board, make a big puddle of solder, and stick your wires in there to get them tinned. So that's the way I tin my transformer. That happens to be a little binocular core transformer that I was tinning. So you can make circuit boards and do your tinning. So I already mentioned kind of there's a lot of technology in the QRP business. And I already mentioned QRPRC as a good club, as well as this Minnesota Technical Society. If you go on to QRPRC, they always have a big convention along with Dayton Hamvention. The 4 days in May, they have 4 days, along with the Ohio Hamvention. So you can go there and touch bases with all these guys that are doing QRP. They have a good show and tell night where you can show off your stuff that you built. You can see what everybody else has built. They have technical presentations. It's a really good thing.
Yeah, I'll insert this, Mert. I've been there twice with him, and both times, if you ever know, it's like walking around with a rock star. Like what's like be with Mert, like Mick Jagger at Rock and Roll Hall of Fame. Walk around with Mert at Dayton, and then 4 days in May. It's like everybody, hey Mert, they all want to come over and see.
It's a lot of fun. And there's a group there called the Flying Pigs that are kind of a bunch of screwballs. But the club was started by a guy named Diz, W8DIZ, and he has a website with kits and parts. He calls himself the Toroid King. You can buy all kinds of toroid kits and toroids from him.
Yeah.
He also has some QRP kits. He just died about a month ago, I think. So he's not around anymore. I'm anxious to see if his website still continues, because you can always get parts from him. Also, another club is the Four-State QRP Club that has a convention in Ozark. It's on today. They got it going today down in the Ozarks, and that's a bunch of guys. About maybe 150 guys show up at the motel down there, and they have they do a Saturday, one all-day presentation. They have a build-a-thon Friday night, and they do a lot of technical stuff. So there are a lot of places, you know, a lot of places where you can get kits already, but there's also one that I would recommend, and that's QRP Labs with Hans Summers. Although I just bought one of his kits, and it blew me. I got it about half done, and I finally gave it up. It was just too tight. I was doing okay. Hadn't made any mistakes yet, but I could see that my next soldering was going to be a disaster. And then I looked at one part that was supposed to have already been pre-soldered, and it looked to me like it wasn't soldered yet. And there was no way I was going to get that soldered. So I passed it on to Craig, and he started looking at it. He took a crack at it, he gave it up too. So that made me feel a lot better. But still, I wasted a whole bunch of time and money on a kit that I never got made. But anyway, he does have, I had made some of his other kits, so he does have some good kits, but that kit thing has to be taken up with a little bit of care. Also, there's QRP Maine, QRP-ME, which is run by a guy named Rex Harper. Rex is W1REX, and he runs the build-a-thon at the 4 days in May every year. I've also mentioned this V-band thing, which I just ran into. That's kind of interesting, but it's only if you're interested in CW. But I still say I've explained why CW was important, because I had to learn it. It was fun, I learned it, but it sticks with me, so it's still kind of fun. So anyway, the whole object for this thing is, hey, this technology thing is big, keep going on it, and I'm sure there's plenty more to come the way you're headed now with all the different modes and all the different circuit components and kits. It's a great hobby. Thank you.
Do you remember when you were running crystal control on your transmitter, that you would put out a CQ and then you tune up and down the band looking for somebody to convert you?
That's right, you could get somebody 200 kilohertz away maybe.
Yep, yeah.
Yeah.
That's changed a lot.
And that's why if you lost them, sometimes you didn't know where the hell he was.
Yeah. Well, Mert, thank you very much. That was really good.
Okay, it's been fun. Thanks for being so patient and
Sure.
listening to an old codger talk about things.
So how long totally were you in the Navy for? How many years?
I was in 7 years, no, 6, I guess.
6 years?
6 years active and 23 in the reserve. I stayed in afterwards primarily thinking of retirement. And I do. I'm a retired guy.
Yeah.
When you had some military equipment, surplus, how'd you get it to tune up to the ham bands?
Oh, most of them were, they covered the handbag.
Oh.
Yeah. There was one, I can't remember the numbers anymore, but they were like BC 696 transmitter. We had a dial on it that covered maybe 6.5 up to 9. So we covered the 40-meter handbag.
I had a 457, BC 457.
And they put on pretty good, they ran 2 1625s in parallel. So you're running maybe 300-400 amp, 300-400 watts DC, and maybe 100 milliamps. So you're running maybe 40 watts input to them or so. They were pretty good little way. And they had a roller inductor to tune. And they not only had the frequency tuning, but this roller inductor was the antenna tuner. So you could set the frequency and then go tune it up to get power to the antenna. That was a really good little rig.
That was
But
aircraft,
that was
right?
strictly CW.
That was out of an aircraft.
Yeah, they used them in aircraft. It was about this deep and about that big on the face. I should have taken some pictures. You can probably Google some of that and see pictures. That's how I got that picture of the F-19R. They got it all on, it's all on the internet. There's some interesting things about the military radio system. There's good stuff about Collins radio. Because Art Collins, who was a ham radio guy, got involved in building military equipment during the war. And so there's a lot of good stuff on there about the various transmitters, receivers, and the people and companies that put them on.